Have you ever wondered what makes metals and non-metals so different from each other? Or why some elements shine and conduct electricity while others are dull and poor conductors? Today we're diving into the fascinating world of metals and non-metals, exploring their unique properties, how they react, and why they are so important in our daily lives. Metals and nonmetals are two broad categories of elements in the periodic table, distinguished by their physical and chemical properties. Now, let's start with the physical properties of metals. First, we have luster. Metals have a shiny and reflective surface, often described as metallic luster. Metals are generally in the solid state at room temperature, except for mercury, which is a liquid. Metals are sonorous. They produce sound when beaten. Malleability. Metals can be hammered or rolled into thin sheets without breaking. Ductility. Metals can be drawn into wires, making them ductile. Conductivity. Metals are excellent conductors of both heat and electricity, with silver and copper being the best conductors. However, lead and mercury are poor conductors. Melting points. Most metals have high melting points, except for gallium and cesium, which melt at low temperatures. Boiling point. Metals generally have high boiling points. Now, let's explore the physical properties of nonmetals. Hardness. Nonmetals are generally soft, with diamond being an exception as the hardest natural substance. Malleability. Nonmetals are not malleable. They cannot be hammered into thin sheets. State. Nonmetals can exist as solids, liquids, or gases at room temperature. Examples include carbon, sulfur, bromine, oxygen, hydrogen, and nitrogen. Nonmetals do not have metallic luster, except for iodine crystals, which can appear shiny. Ductility. Nonmetals are not ductile. They cannot be drawn into wires. Melting and boiling points. Nonmetals in solid or liquid form typically have low melting and boiling points. Conductivity. Nonmetals are poor conductors of heat and electricity. Sonorous. Nonmetals do not produce sound when beaten. Next, we'll look at the chemical properties of metals. Reaction with oxygen. Metals react with oxygen to form metal oxides. Some metal oxides are basic, some are acidic, and some are amphoteric. Potassium and sodium react vigorously with oxygen. They can even catch fire and are hence stored in kerosene. Magnesium burns brightly when heated with oxygen and forms magnesium oxide. Iron glows when heated with oxygen and forms a red layer of iron oxide, commonly known as rust. Copper doesn't catch fire and forms a black copper oxide layer. Silver and gold are highly unreactive. They don't react with oxygen. Self-protecting metals. Metals such as magnesium, aluminum, zinc, and lead create protective oxide layers to prevent oxidation. Reaction with water. Metals react with water to form metal hydroxides and hydrogen gas. The reactivity varies among metals. Sodium and potassium react violently with cold water, producing sodium hydroxide, hydrogen gas, and often catching fire. Calcium reacts less violently with water, forming calcium hydroxide and water without catching fire. Magnesium reacts only with hot water to create magnesium hydroxide and hydrogen. Aluminum, iron, and zinc require steam to react, forming metal oxides and hydrogen. Lead, copper, silver, and gold do not react with water at all. Next, we have reaction with acids. Metals react with dilute acids to form salts and hydrogen gas. The reactivity varies among metals, and some metals do not react with dilute acids. Reactivity order. The metals vary in reactivity. In decreasing order, it is magnesium, aluminium, zinc, and iron. Copper, silver, and gold do not react with dilute hydrochloric acid. Nitric acid. Hydrogen gas is not produced when metals react with nitric acid. This is because nitric acid is a strong oxidizing agent. It converts the produced hydrogen into water while itself getting reduced to various oxides of nitrogen. Reaction with metal salt solutions. More reactive metals can displace less reactive metals from their salt solutions in a displacement reaction. Magnesium displaces copper from copper sulfate solution. Now let's move on to reactions between metals and non-metals. Now let's look at the reactivity series of metals. Most reactive, potassium, sodium, calcium. Moderately reactive, magnesium, aluminum, zinc. Less reactive, iron and lead. Least reactive, copper, mercury, silver, gold. So, how do metals and non-metals react? Metals lose electrons to become positive ions. Non-metals gain electrons to become negative ions. Let's look at some examples of this interaction. Formation of sodium chloride. Sodium loses one electron, chlorine gains one electron. The attraction between the two ions results in the formation of sodium chloride. Formation of magnesium chloride. Magnesium loses two electrons. Chlorine gains one electron. The attraction between the two ions results in the formation of magnesium chloride. Now we'll discuss ionic compounds. Ionic compounds are formed by electron transfer from a metal to a non-metal. Ionic compounds are composed of ions. They are crystalline solids and possess high melting and boiling points. Ionic compounds are soluble in water but insoluble in organic solvents. They conduct electricity when in a molten or solution form. Next, we'll discuss the occurrence of metals. Some less reactive metals like gold, silver and platinum are found in their elemental form in the Earth's crust. Most metals are found in the form of compounds such as oxides, carbonates, sulfides and halides. Minerals are naturally occurring elements or compounds in the Earth's crust. Ores are minerals from which metals can be profitably extracted, while gangue refers to the impurities in the ore, like rock and sand particles. Extraction of metals from ores. Concentration of the ore. This process involves removing impurities from the ore using various methods to obtain a concentrated form of the metal. Reduction to the metal. The concentrated ore is then subjected to a reduction process, typically with the use of heat and a reducing agent, to obtain the pure metal. Refining. The final step involves refining the metal to remove any remaining impurities, resulting in the pure metal. Extraction methods and reactivity. Metals low in activity series. These metals can be extracted by heating their ores in the presence of oxygen. For instance, mercury is extracted from cinnabar by heating it with oxygen, first forming mercuric oxide, which is then reduced to mercury. We hope that you have understood the topic. You can now study chapter notes, watch video lectures, and solve MCQ tests of this chapter on EduRev to ensure you score well in your school exams. And that's not all. You also get amazing courses for maths, science, English, Hindi, and much more for class 10. Thank you